Hey everyone, welcome to Chapter 12. Okay, we're going to be talking all about angle relationships and transformations. So we're going to be able to talk about escalators, chairs, architecture, all right, just to name a couple things, and how the geometry and some of the stuff we learn can be used in designing a building like that, or designing a chair, or designing an escalator, all right? All right, so the first thing let's talk about is just a little bit of angle review. Okay, so if I had that right there, and said, what kind of angle is that? What would you tell me? Well, hopefully you'd say, hey, it's a 90-degree angle. The little box means 90 degrees, okay? Which means, we could also draw it like that, 90-degree angle, okay? But what if I said, what is that angle right there that cuts right through that little box? What would that angle be right there? Well, hopefully you'd say, oh, it's going to be half of 90, so it'd be 45 degrees. And that one right there would also be 45 degrees, okay? So if that's the case, if a right angle forms a 45-degree angle, to pretend that's completely straight, what does that form? Well, a straight line actually has an angle measure of 180 degrees. You could almost think of it as a right angle combined with another right angle. Right angle with right angle, so 90 plus 90 would get you 180 degrees, right? So if you had to figure out the measures, the angles of this triangle, could you? Why don't you try it and see what you get? Alright, so hopefully you'd remember that inside a triangle, all of the angles add up to what? Well, they all have to be 180 degrees, right? So I know that all angles have to equal 180 degrees. So if I add up all these angles, what would that look like? Well, I don't know what they are yet, but we can use what we've been given and the fact that we know all of them have to add up to be 180 degrees to figure out exactly what every angle is. So I'd start here, and that angle right there is x plus 12. Then I'd start with, go to this one, okay, well it's 2x plus 4, so it's a positive 2x plus a 4. And we're adding to that last angle of x, okay? So how would you solve? Well, at this point, we need to combine like terms on the left side. So I have an x, a 2x, and another x. So all those things combined would get me 4x. Then I'd have, let's see, next I'd have the 12 and the 4. Okay, so 12 plus 4 is 16. And again, that all equals 180. So if I were to solve, I need to subtract 16 from both sides first. That would get me 4x equals 164. And then I would just need to divide by 4 and divide by 4. X would be by itself now, and we would get x to equal 41 degrees. So is that the measure of every angle? No. If x is 41 degrees, then what's this here? Well, this angle would be 41 plus 12, which would of course be 51, so then 53 degrees. And this up here would be 2 times 41 plus a 4. So let's see, 2 times 41 would be 82. Okay, this would equal 82 plus 4. 82 plus 4 would of course be 86 degrees. And then here, okay, well we found that x was 41, and this angle here is just represented by plain old x, so it's actually just 41 degrees. Now how can we check our work? Well, if I add 41 to 86 and then add that to 53, I should get 180. And if you do that, you get 180. So these are the measures of all of those angles. All right, so now we're on to 12.1. Okay, so the previous was just review. Now we're talking about getting into the heart of the chapter. All right, so we're talking about angle relationships in Unit 12.1. And let's see, the first thing we're going to talk about is complementary angles. So what are complementary angles? Well, they're angles, two angles whose sum is 90 degrees. So if I had one angle right there, and we'll call it angle number 1, and I had another angle here, and we'll call him angle number 2. Let's say the measure of angle number 1 is 30 degrees, and the measure of angle number 2 is 40 degrees. Well, let's see, would those be complementary angles? Well, do they sum to get 90? Well, let's see, 30 and 40 is only 70. So those are not complementary, okay? But if we had two other angles, okay, oh, and I'm sorry, this whole thing is item number, 1. I already had it up there. Great. Anyway, if I had two angles and one was 60 and the other one was 30, would those be complementary? Yeah, and the reason is this, because the measure of angle 1, okay, so that's how we write measure of angle 1, m angle sine 1, is 60 degrees. But the measure of angle, let's see, this was number 2, angle number 2 is 30 degrees. And if you add those things up, well, guess what you get? 90 degrees. And so they are complementary angles. All right, so next we have supplementary angles, and they are just two angles whose sum is 180 degrees. Okay, so if I had an obtuse angle there, and let's say that's angle number 1, and we'll say that it's 125 degrees. What would be a supplementary angle to that? Well, we know that there's got to be two angles whose sum, the sum of their angle measures, have to be 180, right? So if we had a supplementary angle to that, that would have to be, well, what? Well, it'd have to be 180 minus 125, right? So it'd have to be a 55 degree, that's angle number 2, sorry, 55 degree angle. And those two would be supplementary. Why? Because 125 and 55 add up to get you 180. So again, supplementary means 180. So one way you can remember the difference between complementary and supplementary, okay? When you hear complementary, I want you to think corner. So complement, corner. Because usually, like in most rooms and houses, right, a corner is actually formed by a 90-degree angle. Okay, and then when it comes to supplementary, I want you to think straight line. Okay, so complement, corner, supplementary, straight line. Okay, because that's what would be formed right there. That would be a 180-degree angle formed by those two angles. All right, so I want you to take a second. I want you to pause the video, and I want you to look at this little drawing here and use that to, first of all, name the complementary angles and then name the supplementary angles. So pause the video, try that, and play it when you're done. All right, so I see complementary angles. Well, I know there are angles that have to complement corner, so they need to form a corner or really technically a 90-degree angle. So I see one here and one there that look like they would form a 90-degree angle, and yeah, I probably should have put the box in there. Okay. So, what is this angle here? How do we name that angle? Do we just call it angle E? Well, no. We got to think of an angle as being formed by two rays, and if we remember, a ray has a starting point and then it goes off without ending, right? Never stops, right? That's a ray. So actually what we have here is a ray EC. Okay, now it's not a segment. Now yes, technically there is a line segment EC right there, but really it is a ray. So we would call that thing EC, like that, okay, meaning ray. And we have another ray right here, it's ED. And we have another ray right there. It starts at E and goes through B on into infinity and never stops. So, the question is, what is this angle? Well, we need these rays in order to answer that. And so what we do is we start at one of the rays, and we go down to where that angle sort of is, and then over on the other ray that forms that angle. So I would say that angle CED is complementary to, well, let's see, what other rays form that 90-degree angle? Well, these two right there. Okay, and so we call that ray, angle B, down to the corner of that angle, E, and then over to the other ray, C. Right, so what we would say is that angle CED is complementary to angle BEC. Angle BEC. Right there. Okay. Now, are there any other complementary angles? No, there's not, right? There's only those two angles that form the right angle. But how about supplementary? Well, supplementary angles we know form what? 180-degree angle or straight line, supplementary straight. So the question is, what two angles do that? Well, let's see. Here would be the only straight line, okay, that's present. And let's see. Well, let's see. I got like what looks, if this is a 90-degree angle right there, then that must mean this is also a 90-degree angle. Okay, so what is this 90-degree angle formed by? Well, it's formed by that ray and that ray. And so if I'm going to name this angle, I'm going to start at the A, go to the corner, which is E, and then up to the B. So we would say that angle AEB is supplementary to, well, let's see, what's the other right angle? Well, it's right here, and let's see, it's formed by those two rays, so we would call it, this in blue, B down to the E and over to the D. Angle BED. So AEB is supplementary to BED, because if you combine them, they would give you 180 degrees. All right, so another thing we need to know is vertical angles, okay? So vertical angles, well, when two lines intersect at one point, the angles that are opposite each other all are called vertical angles. So if I had this line right there intersecting that line right there, okay? And let's say we call this 1, 2, 3, angles 1, 2, 3, and 4. So what are the vertical angles? Well, the vertical angles would be 2 and 4. That would be one pair of vertical angles, and we write that angle 2 and angle 4. What are some other vertical angles, though? Well, 1 and 3 are opposite, so we'd say that angle 1 and angle 3 are also vertical angles. All right, so we're going to use what we know to help us solve a problem. All right, so we have this building, so I just found this picture on the internet, thought it was really cool. And you can see we have all these kind of crazy cool angles in there, all right? So we're going to focus in right here. And so we're going to be talking about specifically this. Oh, that looked bad. All right, that right there. I don't know why I never just default to doing the lines. I always try to draw them, and of course I always make them terrible. Anyway, so if we said that that angle, one of those angles there, okay, is, let's say it's 84 degrees. I want to know, we'll call that angle number 1. I want to know what is the measure of angle 2, angle 3, and angle 4. Okay, now how would we do that? Well, so let's remember. We have vertical angles, first of all, because there are two lines that have crossed. So angle 1 and 3 are vertical angles, and angle 2 and 4 are vertical angles as well. Okay, but also we have some complementary, or I'm sorry, not complementary, but supplementary. Okay, because we have some angles that form a straight line. Right, and so I'm thinking first of all about angles 1 and 2. Okay, if you combine those, because they form a straight line, they have to get 180 degrees. So if we know angle 1, we know angle 2, right? Because 180 degrees, take away angle 1 will leave you with what angle 2 has to be, and that's going to be 96 degrees. Angle 2 has to be 96 degrees, okay? And now if we know angle 2, do we know angle 3? Well, actually we do, because again, these angles 3 and 2 form a straight line, right? So angle 2 is 96, so what's angle 3? Well, let's take 180, subtract from it 96. All right, so 180 minus 96 is going to get you 84 degrees. Okay, I'm going to write that there, 84 degrees. And if we know angle 3, then we can know angle 4, because angle 3 and 4 form a straight line with 180 degrees. So if I take that 180 degrees, and we subtract from it the measure of angle 3, which was 84 degrees, we're left with what? 96 degrees. And so that's right there, 96 degrees. So we found the measure of all 4 angles, 1, 2, 3, and 4. Now, what do we notice about the vertical angles? Okay. Well, again, we said angle 1 and 3 are vertical angles because they're opposite, but they're also both the same. They're both 84. And look at angles 2 and 4. Those are opposite each other, so they're vertical angles, and they're both 96 degrees. So when you have two straight lines that cross, the vertical angles are both going to be identical. All right, guys, that's all I have for you. I look forward to seeing you in class talking more about angles.